All right, good morning, everybody. Hope you're all doing well again today. So, what do we got to talk about today? Well, let's finish that one problem I gave you to do yesterday. Make sure we got that down. Here we had to solve for x first and then find the sine, cosine, and tangent of angle theta. Angle theta is over here. First thing we do is what? Make sure that we find the hypotenuse. That's our hypotenuse because it's opposite the right angle. So there's our H. Here's our theta. So with theta, that's our opposite, and that's our adjacent. So first thing we're going to do is solve for x. What do we use to solve for x? To solve for x, we're going to use the Pythagorean theorem. C squared, which is our hypotenuse, is equal to a squared plus b squared, which are our two legs. 9.5 squared equals 5 squared plus x squared. 9.5 squared is 90.25 equals 5 squared, 25 plus x squared. 65.25, I subtracted 25 from both sides, is x squared, and take the square root. So now we know that this x over here, get rid of that. Right, our x over here is equal to, I don't want red. Equals the square root of 65.25. 65.25. Yes, I know the writing on here is horrible, but it is what it is. It's not like I have an actual smartboard in front of me. All right, so now that we know this, we're going to find the sine, cosine, and tangent of this angle here, theta. All right, we're talking about here. So the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. What we have here, the sine of theta is approximately 0.53, the cosine of theta is approximately 0.85, and the tangent of theta is approximately 0.62. Sine, cosine, tangent, opposite over hypotenuse, so TOA. That's what we use to get these numbers here. So hopefully you got those right. So what are we going to talk about today? Well, when you know the lengths of the sides of a right triangle, how can you find the measures of the other two acute angles? If we know all three sides, how do we find those angles? That's what we got to start talking about. So we need a way to find those missing angles in the right triangle in order to be able to solve the triangle. Solving the triangle, it means finding all the measures of all the missing sides and angles. So you'll be given a few pieces of information, whether it's one angle and two sides, one angle, etc. So to find the measures of the sides, we're going to use the Pythagorean theorem, just like we did in the last example, or possibly SOHCAHTOA, that will give us the side lengths. To find the measures of the acute angles in a right triangle, we use the inverse trigonometric functions. These here, inverse trig functions. The inverse trig functions are on your calculator. All you have to know is where those buttons are. It just means that's what we're going to use to find an angle. They're above the sine button, the cosine button, and the tangent button. What does that look like? Now I know this is kind of small, but if you look under the sine button, now I had sent you a link earlier to download a graphing calculator. There's one for the, if you have an Android device, get one that looks just like this. If you have an Apple device, you can get one that's similar to this, but it has the same kind of buttons. Either way, I also gave you one that you could download that would look like this. So in any event, there's our sine button. What's right above the sine button? Sine raised to the -1 power. That's what it looks like there. Sine to the -1. That means the inverse of the sine. That's the inverse function of sine. Above cosine says cosine to the -1. The inverse function of cosine, same thing for tangent. Above the tangent button is inverse tangent. These are accessed. To use these buttons, we're going to press the second key. All of these things, it's yellow. That means everything you hit after you hit second gives you the yellow function. Here it would be second sine to find the inverse of sine, second cosine for the inverse of cosine, and second tangent for the inverse of tangent. All right, we'll be using that in a moment, but they're all accessed using the second key on the calculator. Let's put that down for a second. So what do I mean by that? Well, here we have right triangle ABC. Right? Our hypotenuse is C. The two legs are A and B. The sine of angle A, the sine of A, is opposite over the hypotenuse, A over C. So the measure of angle A, right, all we're doing is taking the sine and moving it over here, is inverse sine A divided by C. A over C is just some number. So it will be second sine whatever this number is, or even just this ratio. Same for cosine, same for tangent. The angle A is going to be second cosine of either. Now for cosine, we've got adjacent over hypotenuse and tangent opposite over adjacent. It's a little easier to see if we put some numbers in there. So we're finding the measures of the angles using the inverse trigonometric function. That inverse function is found on the calculator, second sine, second cosine, or second tangent. That gives us the measure of the angle in degrees. Be very careful now. It's really important that you put the calculator into degree mode. So let's just put some numbers in there, right? And see how this works. So the measure of angle A. We need to find the measure of angle A. Well, the measure of angle A would be the inverse sine of A over C. A, remember where A was? This was A, right? This was B, and this was C. Inverse sine is A over C. A, 21 over 20. Oh, I'm sorry, opposite over hypotenuse, 21 over 29. So how do we get that number? Now notice I have approximately, because it is going to be an approximation. We're going to round to the nearest tenth when we round to degrees. So let's go back to the calculator. This is where we're going to see this, right? And I'm going to turn it on. I'm going to go to mode before I do anything else. Make sure you are in degree mode. In degree mode. Not radian. We're going to talk about radians later in the week or early next week, but in degree mode. Good. We're in degree mode. Now notice I pressed the second button. Yellow is quit. That's why it goes back to the original screen. So how do I find this number? Well, I said the inverse sine is above the sine key. There it is. How do we access that? With the yellow button. So I'm going to hit second sine. Notice what pops up. Sine -1, sine -1. I'm just going to put in exactly what I have here. 21 divided by 29. 21 divided by 29. Now, you should always get in the habit of closing your parentheses when you're doing something like this, on any of these on the calculator. So, now I have exactly what you see here, right? Sine inverse. Let's see if I can. this out. There we go. It's easier to see, it's bigger, right? That's exactly what we had over here. I hit the enter key now, and this gives me an answer. To the nearest tenth, angle A is equal to 46.4 degrees. 46.4 degrees. 46.4 degrees. Right from the calculator. Now, can that angle change? Is it going to be different if I use cosine? It really shouldn't be. I need to see that it gets the same answer for all three of these. So it doesn't matter which one you have. Whatever you want to use, you can use. Sometimes you're going to have two pieces that you can use right away to find the angle. So let's try it with the cosine. How would this work with cosine? Well, let me clear this. I'll leave that there. So what do I need to put in? Cosine is b over c. Adjacent over hypotenuse, 20 over 29. So I'm going to hit the second key, only this time cosine. Now my numbers have changed slightly. It's 20 divided by 29. When I hit enter, I really expect to see this same number. And look at that, I do. All the digits are the same actually, which is nice. But we're still only rounding to the nearest tenth, so it's 46.4 degrees. So what I'm showing you now is just that it works for all of these functions. Tangent. Do you think we're going to get 46.4 degrees if we do it with the tangent? Well, what's the tangent of angle A? Tangent is opposite over adjacent. A over B, 21 over 20. Go back to the calculator. Second, because I want to access the inverse tan function, 21 divided by 20, close my parentheses, enter, and it's exactly the same number. 46.4 degrees. So this worked exactly the same for all three functions, and it better have. Let me ask you a question. If I know that this angle is 46.4, how do I find B? Well, we know that the angles of a triangle add up to be 180, or that the two acute angles in a triangle are complementary. So I can subtract this from 90 degrees and get what angle B is. Then we would have solved this triangle. Look at that. We would have had all three sides and the other two acute angles. We already know that this is 90 degrees. So let's look at angle B now. Things are going to change slightly. And I'm going to put different numbers in for angle B. I probably should use the same numbers, but that's okay. So if I'm at angle B, things change now. Angle B, the opposite from angle B. If I'm over here now, opposite angle B is over there. Adjacent to angle B is over there. C is still my hypotenuse. So the sine of angle B is equal to B over C. Cosine is A over C. Tangent is B over A. More importantly for today, the measure of angle B is the inverse sine of B over C, or the inverse sine of A over C, or the inverse sine of B over A. So let's take a look at that with some numbers as well. So here, three different numbers. Not the same as the last problem, but I'm trying to find angle B this time. Measure of angle B is equal to the inverse sine of B over C, which is the inverse sine of opposite over hypotenuse. We're at angle B. We're over here, opposite hypotenuse. Go back to the calculator. And clear these out for that problem. So second, sine 8 divided by 17. 8 divided by 17. Close parentheses, hit enter. 28, be careful of rounding, 28.1 degrees. That 7 makes a 0 go to 1. That's approximately 28.1 degrees. Well, that was the best numbers I've drawn so far. Angle B. If I use the cosine, I should get the same angle, only this time cosine is adjacent over hypotenuse, 15 over 17. Second, cosine 15 divided by 17, close your parentheses, enter. Amazing, 28.1. And I assume at this point you're going to figure out that I could have used a tangent as well to get that 28.1 degrees. Second, tangent. Tangent is opposite over adjacent, 8 over 15. And of course I get 28.1 degrees. So while we're here, let me ask you, we now know that this was 28.1, right? How could I find angle A? Angle A. Well, I could go back to all my ratios like I did before, but what is 90 minus 28.1? 90 minus 28.1. 61.9 degrees. So if I'm right, this angle here should be, I'm sorry, what did I say it was? 61.9. Ooh. That's because I made it too thick. Is that true? What ratio can we use to verify that? Let's use the tangent. What is the tangent of A in this particular triangle? Let's go to thinner. Tangent of angle A is equal to opposite over adjacent, right? 15 over 8. So what would the measure of angle A be? The measure of angle A is equal to inverse tangent of 15 divided by 8. Let's go back to our calculator. Second tan 15 divided by 8, 61.9 degrees. Amazing. So this is solving a triangle. We'll get more to that later. So let's practice a little just with the calculator and the buttons. Let angle A, B, and C be acute angles. Use a calculator to approximate the measures of angle A, B, and C to the nearest tenth of a degree. So here I have tangent of A is equal to 0.75. Notice this time I don't have a ratio. Doesn't matter. If I have a decimal, I can always turn a fraction into a decimal by actually dividing. So to find angle A, we use second tan 0.75, and I get approximately 36.9 degrees, right? Let's verify that on the calculator. Clear. Second tangent 0.75. Enter. 36.9 degrees. 36.9 degrees. Same thing here. Suppose I'm at B, and I know that the sine of angle B is equal to 0.87. That's its ratio. That's its opposite over hypotenuse, is 0.87. So the measure of angle B is equal to inverse sine 0.87, approximately 60.5 degrees. Second sine 0.87. You don't have to put the zero in. It's just nice to do sometimes. Enter. 60.5 degrees to the nearest tenth. And on this one, our cosine is equal to 0.15. The measure of angle C is equal to second cosine 0.15. Second cosine 0.15. 81.4 degrees, and that's exactly what we got. So now I have 3 for you to try. I will give you 5 minutes or so, then I'll put the solutions up, then I'll give you some work to do tonight, and we'll be done for today. So let's take 5 minutes to try to figure this out. Take your calculators out. Second tan 0.43. Second sine 0.68. Second cosine 0.94. Write it out, please, as well. I'll show you when you see the solution. So I'll give you 2 minutes. These are pushing buttons on the calculator. Shouldn't take you that long. So I'm going to ask Siri again to time me for 2 minutes. Hey Siri, set a timer for 5 minutes. Oops, sorry, I said 2 minutes. 2 minutes starting now. All right, should have been long enough. You should have answers. Let's see if you got them correct. I'm going to send this as a PDF file as well. These links will be active in that. You can always go and look again. So let's see what it does.
Let angle G be an acute angle. Use a calculator to approximate the measure of angle G to the nearest tenth of a degree. Tangent of G equals 43 hundredths. So you are given that the tangent of G equals 43 hundredths. Then you can use the inverse of tangent to find the angle measure. So the measure of angle G equals the inverse tangent of 43 hundredths. Then use a calculator to approximate the measure, which gives that the measure of angle G is about 23 3/10 degrees. Thus, the measure of angle G is about 23 3/10 degrees.
All right, so did you get that? Hopefully. Let's look at the next one.
Let angle H be an acute angle. Use a calculator to approximate the measure of angle H to the nearest tenth of a degree. Sine of H equals 68 hundredths. So you are given that the sine of H equals 68 hundredths. You can use the inverse of sine to find the measure of the angle. So the measure of angle H equals the inverse of sine of 68 hundredths. Using a calculator to approximate the measure gives the measure of angle H is about 42 8/10 degrees. Thus, the measure of angle H is about 42 8/10 degrees.
All right, hopefully you got that one as well. And let's look at the last solution.
Let angle K be an acute angle. Use a calculator to approximate the measure of angle K to the nearest tenth of a degree. The cosine of K equals 94 hundredths. You are given that the cosine of K is 94 hundredths. You can use the inverse of cosine to find the angle measure. So the measure of angle K equals the inverse of the cosine of 94 hundredths. Use a calculator to approximate the measure, which gives the measure of angle K is about 19 9/10 degrees. Thus, the measure of angle K is about 19 9/10 degrees.
All right, so hopefully you have those solutions, you have those answers. You can always, again, click on this when I send you the PDF. And I'm going to try to do this in smaller chunks as we go forward. Some days will be longer than others, but this is what I want you to do tonight. Just find the measures of these 6 angles using a degree. And tomorrow we'll talk about solving triangles using all the things. We'll put it all together. Hope you have a great day. If you have any questions, I'm here from 9:30 to 12:30. And talk to you soon. Stay safe, stay well. Bye-bye.